Hello, we're going to go over section 13.2, arithmetic sequences. So before I begin, I'm just going to warn you ahead of time that I have the most difficult time pronouncing that word, arithmetic. So if I sound funny, please excuse me. Alright, so let's go with the definition. An arithmetic sequence may be defined recursively as a sub 1 is a, meaning the first term is a, and a sub n minus a sub n minus 1 equals to d. Now a is the first term and d is called a common difference. Now let's derive the arithmetic formula. So first term is always going to be a. The second term is a sub 1 plus d, which is a common difference. Now I can write that as a sub 1 plus 1d. And the third term is second term plus the common difference. But the a sub 2, the second term, we just computed that to be a sub 1 plus 1d. So I'm going to replace that in place of a sub 2. And if I add them all together, we're going to have a sub 1 plus 2d. We're going to keep doing that, but do you notice the pattern? The sequence follows the pattern of a sub 1 plus d, a sub 1 plus 2d, a sub 1 plus 3d, and so forth. Then here comes the theorem. Nth term of an arithmetic sequence. For an arithmetic sequence an, whose first term is a sub 1 and a common difference d, the nth term is defined by a sub n equals the first term plus n minus 1 times the common difference d. Let's do some examples. Example 1 is the sequence arithmetic. If so, find the first term and the common difference. So here I have written 3, 6, 9, and 12. So let's, first one is the easiest one. The first term is going to be 3, as you can see. So let me just write that. First term is 3. So we got that much. Now, do we have any common difference here? So let me see. Starting from 3, in order to get 6, I need to add 3. From 6, how can I get to 9? Add 3. And then from 9 to 12, add 3. So, yes, we do have a common difference, and this sequence is going to be arithmetic. So, in this case, first term is 3, and our common difference, d, is going to be 3. So, let me just box these two. And, oh, I should answer, yes, it is arithmetic. Let's take a look at another one. So we're given that infinite sequence an equals 3n plus 1. So I'm just going to show you how to do this in two different ways. But the most general way to do it would be just computing the first term, which will be a sub 1. So a sub 1 is going to be 3 times 1 plus 1, so that's 4. Now let's go with a sub 2, and this is going to be 2 plus 1, so this is 7. A sub 3 is 3 times 3 plus 1, so which is 10. A sub 4, 3 times 4 plus 1, which is 13, and then we're going to keep going. Now, let's go with the first term. Is going to be 4. Now, do we have any common difference, and is this arithmetic? So let's count, let me see, from the first term to the second term, I added 3. Second term to the third term, another plus 3. So yes, it does look like we have a common difference of 3. So yes, this sequence is arithmetic. So let me write that out. And common difference d is 3. So yes, it is arithmetic. So let me just box this. Okay, now let's try to look at this in a little bit of a different way. So our a sub 2 is 7, and then a sub 1 is 4. So 7 minus 4 gives us 3, right? And then the difference between a sub 3 and a sub 2, 10 minus 7, that's 3. So in fact, isn't this what we're doing? Our common difference d is nothing but maybe a sub 2 minus a sub 1, or a sub 3 minus a sub 2. So in general, our common difference d can be defined by a sub n minus a sub n minus 1. And let me box that because this is a very, very nice formula. So let's try to do this problem by using d equals a sub n minus a sub n minus 1 to see what we get. So if we use that, then first of all, our a sub n is 3n plus 1. So a sub n minus 1 is 3 times n minus 1, and then plus 1, which is 3n minus 3 plus 1. So a sub n minus 1 is going to be, what is that, 3n minus 2? Okay, so therefore, our common difference d can be defined by a sub n minus a sub n minus 1, which is 3n plus 1 and then minus 3n minus 2. So simplify. And 3n is going to cancel each other out. So what we're going to get is 3, as we expected. Okay, let's do another example. So our sequence is given by 4 minus 2n. So our job is to determine whether this sequence is arithmetic or not. But let's try this out. So our first term, which will be s sub 1, is 4 minus 2 times 1. So that will be 2. So that's our first term. So I'm just going to write it as first term s sub 1 is 2. Okay, so now let's try to find a common difference by using that formula. So common difference d can be found by a sub n minus a sub n minus 1. So let's work it step by step. So first, we're calling this sequence s sub n, so I apologize. So maybe I should change that to a s instead. Okay, so now our s sub n is 4 minus 2n, and then s sub n minus 1 is 4 minus 2 times n minus 1. And if we simplify that, what do we get? 4 minus 2n, and then plus 2. So in this case, what we're going to get is, what, 6 minus 2n. So let me just box this. Box that. Alright, so now let's see. So our d is s sub n minus s sub n minus 1, which is 4 minus 2n, and then minus 6 minus 2n. So this is going to become 4 minus 2n minus 6 and then plus 2n. And these two are going to cancel each other out. So yes, we are able to find a common difference, and common difference d is negative 2. So just for fun, let's just do another one. So feel free to pause the video and try this on your own. Alright, so first term is going to be t sub 1, so which is 1/2 minus 1/3, which is 1/6. Now let's go with the common difference, if there is any. So d formula is t sub n minus t sub n minus 1. So our t sub n is defined as 1/2 minus n/3. And t sub n minus 1 then, it's going to be 1/2 minus n minus 1 whole thing over 3. Let's just simplify a little bit. So this is 1/2 minus n/3. Remember, you're going to have to distribute the negative sign, and then plus 1/3. So it looks like our t sub n minus 1 is going to be, what is that? 5/6 minus n minus 3. Alright, so let's plug it in. So our d is going to be t sub n, and then minus t sub n minus 1. So what do we get? 1/2 and then minus n over 3 and then minus 5 over 6 and then plus n over 3. All right, looking good. So we can cancel these two out. And what we're going to get is, what is that? Negative 1/3. All right, so therefore, our common difference D is going to be negative 1/3, and the first term is 1 over 6. So you're probably wondering, when does it not become an arithmetic sequence? So here, all of the examples that we just did, we're able to solve for D, but the D was just a numerical value. It was a constant. So that tells you that it is going to be an arithmetic sequence. However, if you have n, the letter n, flying around in that expression for D, that means that there is no common difference. So therefore, it is not going to be an arithmetic sequence. Now let's look at something like this. Find the nth term of the arithmetic sequence a sub n. So we're all given an arithmetic sequence here. So let's go with part A. 80th term of the sequence, negative 1, comma 1, comma 3, comma yada yada yada. So let's first try to compute the common difference. So from here to here, what do we need to do? Add 2, and then 1 to 3, we need to add 2. So it looks like our common difference is going to be 2, and the first term, which is a sub 1, is negative 1. D is 2. Now to find the 80th term of this sequence, we need to use this formula here. So note that the nth term of an arithmetic, I'm just going to write it like this, sequence, is given by a sub n equals a sub 1 plus n minus 1 d. So let's try to follow this formula to compute the 80th term of our sequence. So I'm just going to go like that. So let me rewrite. A sub n is a sub 1 plus n minus 1 times d. Now, since we want to find the 80th term, our n is 80. So we're going to have a sub 80 equals a sub 1, which is the first term, that's our negative 1, plus 80 minus 1 times d. Oh, d is 2. Sorry, let me just erase that. So then this is going to become negative 1 plus 79 times 2. And this is going to equal to 157. So basically, if you keep going negative 1, comma 1, comma 3, and the next one should be 5, the 80th term of that is going to be 157. I think that's pretty cool formula, but here it is. Now let's take a look at this problem. 80th term of 5, comma 0, comma negative 5, and yada yada yada. Okay, so feel free to pause the video and try this on your own and see what you get. Okay, so let's start from 5 goes to 0. That means what? I had to subtract 5. And then 0 to negative 5, I need to add negative 5 to it. So it looks like our common difference is going to be negative 5. And yes, common difference can be negative. So let me first write down our first term is 5, and common difference is negative 5. So we're going to put this into our formula. A sub n equals a sub 1 plus n minus 1 times d. So a sub 80 is 5 plus 80 minus 1 times negative 5. So here, what do we get? 5 plus 79 times negative 5. So this is negative 395 plus 5. So I believe this is going to be negative 390. So let me box that, and that's our answer. Let's do something different. So example 3, find the first term and the common difference of the arithmetic sequence. Give a recursive formula and find the formula for the nth term. So let's try. Fourth term is 3 and the 20th term is 35. Okay, now let's note again. I'm going to write down this formula again. A sub n equals a sub 1 plus n minus 1 times d. And let's jot down what we have so far, what we're given, I should say. We know that the fourth term is 3, so a sub 4 is 3. And then also a sub 20 is 35. Now applying that formula above, so let's first go with a sub 4. A sub 4 is going to be a sub 1 plus 4 minus 1 times d. But a sub 4 is 3, so I'm just going to set that equal to 3. And then also, let's just take care of the a sub 20 as well. So a sub 20 is a sub 1 plus 20 minus 1 times d, but a sub 20 is 35, so I'm going to set it to 35. And just for the organization purposes, let me call the first equation 1 and the second equation to be 2. So now what I'm going to do is I'm going to simplify equation 1 and 2 and stack them up together. So circle 1 is going to be a sub 1 plus 3d, but this is gonna be 3. And circle 2 is going to be a sub 1 plus 19d equals to 35. Now let's take a look at that. That's nothing but a system of linear equations. So let's try to eliminate a sub 1 by multiplying by negative 1 to the bottom equation. So what I'm going to do is that. Alright, let me rewrite. So then what we're going to get is a sub 1 plus 3d equals to 3. Negative a sub 1 minus 19d equals to negative 35. Now, if I use the addition method, a sub 1 is going to cancel each other out. Now here what we're going to get is negative 16d equals to negative 32. So that means d is 2. So we got our common difference by solving the systems of linear equations. Now to find a sub 1, the first term, plug that d value into either one of the equation. Pick a cute one. To me, the top one, circle 1, looks cuter, so I'm going to use this. So let me just write, plug this into, doesn't matter which one, I'm going to plug it into circle 1. So what we're going to get is a sub 1 plus 3 times 2 equals to 3. So that implies that a sub 1 is going to be negative 3. So we got our first term and the common difference. Next, what we need to do is we need to give a recursive formula for this. So let me just write it down. So recursive. That's given by a sub 1 is a, and then a sub n equals a sub n minus 1, and then plus d. So now let's follow this formula. So our a sub 1 was negative 3, and then our a sub n equals a sub n minus 1, and then plus the common difference, which is 2. So this is what the question is asking you to find. That is our recursive formula. And we're not done yet. We got the recursive formula now, and it says to find the formula for the nth term. So let me just write everything out. So nth term formula is given by a sub n equals a sub 1 plus n minus 1 times d. Now let's follow that formula, and we're gonna have a sub n is negative 3 plus n minus 1 times 2. Let's simplify. So a sub n is negative 3 plus 2n minus 2. So our nth term formula is going to be a sub n equals 2n and n minus 5. And so this is all what the question's asking you to find. Let's do another example. So why don't you try this on your own and see if you can get it or not. So just pause and try it. So let's jot down what we have. We have that a sub 5 is negative 2, and then a sub 13 is 30. Now let's write down the formula for a sub n. A sub n is a sub 1 plus n minus 1 times d. So that implies that a sub 5 equals a sub 1 plus 5 minus 1 times d. But a sub 5 is negative 2, so you're going to have to set that equal to negative 2. And then our a sub 13 is a sub 1 plus 13 minus 1 times d, but a sub 13 is 30, so I'm going to set that equaling to 30. And let's simplify a bit. So I'm just going to call this one circle 1, circle 2. So the circle 1 is going to be a sub 1 plus 4d equals the negative 2. And then second one is going to become this, 12 times d. Alright, and then this is going to equal to 30. So now we're going to have to solve the systems of linear equations here. So what I would do is multiply everything by negative 1 on the bottom equation. And then what do we get? Let's rewrite. Then we get a sub 1 plus 4d equals to negative 2. And negative a sub 1 minus 12d equals negative 30. So that's negative 8d equals negative 32. So that implies that d is going to be 4. Alright, so the common difference is done. Now to solve for a sub 1, plug this into either one of the equation 1 or equation 2. So I'm going to say plug this into whichever equation. I'm just going to take circle 1. So if I do that, then here I'm going to get is a sub 1 plus, let me write everything out. 4d equals negative 2. So what we're going to get here is a sub 1 plus 4 times 4 equals to negative 2. So that implies that our a sub 1 is going to be, what the heck is that? Negative 2 minus 16, so minus 18. So we got our first term and the common difference. And what the heck is next again? Recursive formula. Alright, so let's go with the recursive. Alright, now remember again, the formula is a sub 1 equals to a. And then a sub n is a sub n minus 1, and then plus d. Okay, so what do we get here? So our a sub 1 is negative 18. And then our a sub n is just going to be a sub n minus 1, and then plus d. D was 4. So this is our recursive formula. Alright, now what do we have to do? Nth term. The formula for that is a sub n equals a sub 1 plus n minus 1 times d. Okay, so for this particular problem, we're going to have a sub n equals, a sub 1 was what? Negative 18. And then plus n minus 1 times 4. All right, so then simplify a bit. So plus 4n and then minus 4. So therefore, our nth term formula is going to be negative 22 plus 4n. And we're done. Great job, everyone. And if you have any questions, you know where to find me.